discussed in yesterday's class. The very first point that we had discussed was about the properties of positive integers. There are two important properties. One is Euclid's division lemma, also called algorithm, and second one is fundamental theorem of arithmetic. As I said, both the statements are very important in the examination point of view. Just we shall go for recalling the statements of both. According to Euclid's division algorithm, if A and B are any two positive integers, then there exist two unique positive integers, Q and R, satisfying the statement that A equal to BQ plus R, where 0 is less than or equal to or less than B, and B is not equal to 0. This is very important statement. And second one, fundamental theorem of arithmetic. According to this, every composite number can be expressed as the product of composite number can be expressed as the product of its prime factors, and this prime factorization is unique apart from the order in which the prime factors occur, right? And even we have come across the important applications of both. One of the application of Euclid's division algorithm, this is used for finding the HCF of given positive integers. Even we focused on finding the HCF of positive integers by using Euclid's division lemma. Hope that you all have practiced, and this concept is also important in the examination point of view. Then after that, we come across how even number and odd numbers can be expressed. In general, even number can be written in the form of either 2Q or 4Q, 6Q, 8Q, and so on. Similarly, odd numbers can be expressed in the form of either 2Q plus 1. If you go for taking 4Q plus 1, then you can also take one more, that is 4Q plus 3. Next, if you take 6Q plus 1, then in other form, it can be written as, odd numbers can be written as 6Q plus 3, 6Q plus 5. Similarly, it can be continued. Yesterday, we come across two important statements. That is, one is every even positive integer can be written in the form of 2Q, and every odd positive can be expressed in the form of 2Q plus 1, right? So now, let's go for continuing to prove some statements. I think the second problem was over. Now I'm going to take the third one. Yes. And without fail, please write today's date. Even I too have written. Today's date is 15/5/2021. Yes. And I would like to share one more important thing, that yesterday I had given you the worksheet questions in the evening. That is at 5:30. Even every day, worksheets will be given in the same timing. Yesterday, many have written and they have submitted their worksheets as well. I really appreciate those students. And another information is, I request every student to sit at 5:30 in the evening for working out and utilize the time for practicing the syllabus what we covered on the particular day. Okay, now let me go for taking the third problem. Right.
Sir, I have a doubt, sir.
Yes.
In yesterday's problem, sir.
Uh-huh.
1 minute, sir.
Quick as possible.
The fourth Fourth main, second one, sir. 240 and 6,552. I'm
Finding
getting
the
little
HCF,
confusion in that, sir. Yes, sir.
finding the HCF of those two positive integers. You can go for
Yes,
finding them by using Euclid's division lemma. So you had in every step it should be written in the form of A equal to BQ plus R. You just try that, and if you are stuck in between, please get the photocopy of that and send that to my WhatsApp number. I'll clarify.
I have sent you, sir.
Is it?
Yes, sir.
I think evening after 7:30.
Yes, sir.
Yeah. Please, I request every student to attend the doubt clarification class from 6 to 7:30. 6 to 7:30 in the evening. Okay. Now, let me go for writing the fourth statement. It is from the textbook only. Please go for writing with me. Go on writing with me. It is show that any positive odd integer is of the form. Show that any positive odd integer is of the form either 4q plus 1 or 4q plus 3, where q is some integer, right? Where q is some integer. Even this statement was also given in the worksheet. Hope that most of you might have thought. Anyhow, once you go for proving this statement, go on writing with me. Yes, write the proof. Once you go through the given statement, we have to prove that a positive odd integer can be written in the form of 4q plus 1 and 4q plus 3. Of course, these two are in the form of these two are two forms of odd integer, but it should be proved. We do not know what is positive integer. First, let's go for assuming that. Right. Let A be the positive integer. Be the positive integer. Then, right, A is greater than B. If A is greater than B, you can go for applying Euclid's division lemma or Euclid's division algorithm. According to this, it can be written as A is equal to BQ plus R, where 0 is less than or equal to R less than B. Call it as statement 1. Here, we are going to express odd integer in the form of 4q plus 1 and 4q plus 3. In place of divisor, 4 is there, right? Hence, let's go for substituting 4 in place of B. Right here. Substitute B equal to 4 in statement 1. Then statement 1 can be written as A as it is, then B is 4, that is plus, and 4q plus R. A equal to 4q plus R. If 4 is the divisor, then the possible remainders are, they are 0, 1, 2, and 3. Yesterday only I have told you how to take the possible remainders for the given divisor. Here 4 is there, hence the possible remainders will be from 0 to 3. Now let's go for substituting these possible remainders in this statement. Right. If r equal to 0, first one, it is a equal to 4q plus 0. If 4q plus 0 is there, it can be written directly as 4q only, right? And please stop writing and observe the point. Whether 4q is an even number, even integer. Of course, it is an even integer. The reason is it is divisible by 2, or it is also the multiple of 2. Just look at 4q can also be written as 2 into 2q. Okay, it is multiple of 2, hence it is divisible by 2. If it is divisible by 2, then it is called an even number. Next, right, r equal to 1. If r is equal to 1, then we can write a is equal to, it is 4q plus 1. 4q plus 1. We know that 4q is even number. If 1 is added to any even number, you get odd number, right? Next, if r equal to 2, then a is equal to 4q plus 2. Observe. Now let us check whether 4q plus 2 is an even number or not. We can write 4q plus 2 as, okay, here we have two terms. We can go for taking 2 as common factor. Then you will get 2 into 2q plus 1. 2 2s are 4 into q plus 2 1s are 2. See that this is the multiple of 2. Hence, it is an even number. Next, if r equal to 3, if r equal to 3, then a equal to 4q plus 3. See, 3 is an odd number. It has been added to even number. Hence, you will get again odd number. Hope that you all have understood. Now, you may call these statements as, it is second one, this is third one, this statement is fourth, and this is fifth. Observe the statement 2 and 4. These two statements are divisible by 2, therefore they are even. Whereas statement 3 and statement 5, they are not divisible by 2, hence they are odd. So that should be written, right? Statements 3 and 5. 3 and 5 are not divisible by 2, are not divisible by 2. Therefore, they are odd. They are odd. They are means 4q plus 1 and 4q plus 3. Hope that you all have understood. Now, you may go for writing the final conclusion. That is, hence, right, every even positive integer is of, every odd positive integer is of the form either 4q plus 1 or 4q plus 3. The odd number will also be in these forms. Hope that your writing is over. Now, I'm going to give you another important statement which is related to the problem like this only. And the statement what I'm going to give you now, this was asked in the examination nearly 4 to 5 times in last 11 years. So for fourth one, put 3-star mark and write the statement with me. Yes, it is also from the textbook. Write fourth one and put 3 star mark. The statement is like this. Show that any positive odd integer, show that any positive odd integer is of the form just observe it. Don't go for writing, stop your writing and look here. Show that any positive odd integer, we have already come across how to write the odd positive integers. It may be in the form of either 2q plus 1 or 4q plus 1 and 4q plus 3. If I go for taking 6q plus 1, then what other possibilities? Anyone can respond for this.
Q plus 3,
Very good. 6q plus 3.
6Q plus 5,
Very good. 6q plus 5. What is
6Q plus 7,
6q
Plus
plus 7.
Don't go for taking 6q plus 7. The reason is that remainder will be more than the divisor. What is? We all know that remainder will always be less than the divisor. Hence, you may stop up to here. But in the examination, what changes they had made? Very simple change. In place of q, they had given 6n. 6n plus 1, 6n plus 3, 6n plus 5. Like this. Now, please continue. Integer is of the form. I'll give you the statement how it was given in the examination. Right. It is 6n plus 1. Put comma. Right. Or 6n plus 3. Again put comma. Or 6n plus 5. Where n is some integer. Where n is some integer. As you have already learned how to go for proving this type of statement, then please go on writing with me. Right? It is prove. Right. We do not know what is that positive integer. So let us assume that positive integer as a. Right. Let the positive integer be positive integer be a, or a be a positive integer. Then and a is greater than b. If a is greater than b, then you can go for using Euclid's division algorithm. According to this, you can write it as a equal to bq plus r, where 0 is less than or equal to r less than b. You may call this as statement 1. Then observe what is in the place of divisor?
6,
6. Right. Substitute 6 in place of b. Just continue, I'll come. Okay, continue that. Now substitute b equal to 6 in statement 1. Then statement 1 can be written as a equal to 6q plus r. Then the possible remainders will be, It is R equal to 0, 1, 2, 3, and 4. Now go for rewriting the statement by substituting these numbers in place of R. Right. If R equal to 0, then we can write it as A equal to 6Q. Next, if R is equal to 1, just observe and stop writing. Okay.
Sir.
Here, it has been given that it should
Sir.
be expressed in the form of 6n plus 1. Hence, we need to substitution for even Q as well. Just go for including here. Substitute B equal to 6 and Q equal to N.
Sir,
Means,
instead of Q, we can write N now, sir.
yeah, right, here it is 6n plus R. Now, it should be 6n. Next, if R equal to 1, A equal to 6n plus 1. Then if R is equal to 2, A equal to 6n plus 2. If R equal to 3, A equal to 6n plus 3. One more should be added, 5. If R equal to 4, A equal to 6n plus 4. If R equal to 5, A equal to 6n plus 5. Now you may call these statements as it is 2, this is 3, is 4, and this is 5, it is 6, and is 7. You can notice that here statement 2, 4, and 6, they are all the multiples of 2, or they are all divisible by 2. Hence, they are even. Got it? Write that. Statements 2, 4, and 6. Statement 2, 4, and 6 are divisible by 2. Therefore, they are even. Whereas statement 3, 5, and 7, right? They are not divisible by 2. Statement 3, 5, and 7 are not divisible by 2. Divisible by 2. Therefore, they are odd. Which are those? One is 6n plus 1. Second one is 6n plus 3. And third one is 6n plus 5. Write the same. 6n plus 1, 6n plus 3, and 6n plus 5 are odd. Hope that you have written up to there. Now you write the final conclusion. The conclusion is, hence, any positive odd integer is of the form 6n plus 1, 6n plus 3, or 6n plus 5. Write that final conclusion. Once I repeat, it is, hence, any positive odd integer is of the form 6n plus 1, 6n plus 3, or 6n plus 5. Hope that you have written. Now we are moving to the next type of problem. In the next type, we will focus on the statement problems. We all know that Euclid's division algorithm is used for finding the HCF of given positive integers, right? So now let's go for taking some of the applied questions related to Euclid's division algorithm. Right, fifth one. Fifth one. Right. 2 tankers contain 850 liter and 680 liter of kerosene oil. 2 tankers contain 850 liters and 680 liters of kerosene oil respectively. Full stop. Right. Find the maximum capacity of a container. Find the maximum capacity of a container which can measure the kerosene oil. Which can measure the kerosene oil of both the tankers. When used an exact number of times. When used an exact number of times. Write the full statement correctly. Hope that you all have written. Now, go through the statement. The statement is 2 tankers contain 850 liter and 680 liter of kerosene oil respectively. There are 2 tanks. In first one, the capacity of the in the first tank, there is 850 liters of kerosene oil, and second tank, 680 liters of kerosene oil. And you are going to find out the maximum capacity of a container which can measure the kerosene oil of both the tankers when used an exact number of times. Means you are going to use a container, and this container should be used to empty the kerosene oil present in both the tankers. And when you are emptying, it should be exact number of times. Like there should not be half amount of kerosene oil in the container. There must be exact number. Either it should be emptied by 10 times, 20 times, 30 times, 21 times, not 21.5. Got it? As we are going to take out the kerosene oil from the in the container by using the in the tanker by using the container, every time we are dividing that, every time we are removing it, hence it belongs to HCF, highest common factor. So to find out the maximum capacity of the container, we should find out the HCF of these 2 numbers. Hope that you have understood. And don't think that if there is maximum, we have to use HCF. And if it is minimum, we have to use LCF. So you have to understand the statement. Based on that statement, you have to decide whether it belongs to HCF or LCF. Very simple thing is, if the situation in which if it is to be divided, it belongs to HCF. If it is going to be multiplied, then it is LCF. Clear? Here, this situation belongs to HCF because we are going to remove the kerosene oil by using the container every time we are dividing it. Yes. As it is a statement problem, it needs some required steps. They are, first one is data, second one is calculation, then third one is final conclusion. So please do follow the same. Right. Data. What has been given? They are given the quantity of kerosene oil present in both the tankers. So here I'll write quantity of kerosene oil in the first tanker. In the first tanker, this is 850 liters. Right, 850 liters. Second one, quantity of kerosene oil. In the second tanker, this is 680 liters. 680 liters. Then data, let's go for calculation. And we have to give the information whether the statement belongs to HCF or LCF. That must be written without fail. You are going to find out the maximum capacity of the container. Right. Maximum capacity of the container which is used to empty the kerosene oil from the tankers in exact number of times. Therefore, it belongs to HCF. Right. It is HCF of these two numbers, 850 and 680. Right. 850, then 680. This statement, half marks will be considered. Please do remember. Next, further, we know that we have already learned how to find out the HCF using Euclid's division algorithm, right? So let's go for using that. Here, 850 is greater than 680. Hence, use Euclid's division algorithm. Then we can write it in the form of A equal to BQ plus R. As it is simple number, you can go it directly, or else you may use working part. Let us divide 850 by 680. It is 680 ones up. 680 ones are 680. Subtract, you get 0. 15 minus 8 is 7. Then 7 will remain. 7 minus 6 is 1. 7. So let us write 850 can be written as 680 into 1 plus 17. Here the remainder is not equal to 0, hence it can be continued. Now divide 680 by 17. 680 by 170. Just by observing only, you can come to know that here 68 is the multiple of 17. You are very familiar with the table 17. 17 fours are. Very good. 17 fours are 68. Then 170 fours are 68. It's very simple. Right. 170 fours are 68. Remainder will be 0. 680 can be written as 170 fours are plus 0. As the remainder is 0, then the divisor will be HCF. You can write HCF form 850 and 680 is 170. Follow. Next, write the conclusion. Conclusion is So the maximum capacity of the container, which can measure the kerosene oil of both the tankers when used an exact number of times, is 170 liter. So let us write the conclusion in short as, therefore, the maximum capacity of the container is the maximum capacity of the container is 170 liters. The maximum capacity of the container is 170 liter. Hope that you have written this. And for how much marks you can expect this statement?
5 marks.
2 marks.
It is for 2 marks. It is for 2 marks. Now, how the marks will be allotted? Let me tell
2
you.
marks.
Yes, it is for 2 marks. Here, including data to give this information, that is maximum capacity of the container can be found out by using the concept called HCF. It is half mark. Next, for using Euclid's division algorithm or lemma, for each step here, half marks. See, this is half marks and this step is for half marks. And you'll find that HCF 170, including this conclusion, half marks. Now, you may count it. See that here, half plus half plus half plus half. Totally, it is to be asked for 2 marks. Even the previous problem as well, that is also for 2 marks. Hope that you have understood this. Now, I'll go for taking another statement which has been given in the textbook. Now, let me rub this. Once you go through the steps what you have written in your notebook. Hope that all of you are maintaining the notes, and soon after every problem, go for drawing a line with pencil. Then it looks good. Yes, one more step. Now it is 6th one. It is from the NCERT textbook. Right. A sweet seller has 420 Kaju Barfis. And 130 Badam Barfis. And 130 Badam Barfis. Then she wants to stack them in such a way that is sweet seller. She wants to stack them, arrange them, packing them, to stack them in such a way that each stack has the same number. That each stack has the same number. Means each arrangement has same number of Barfis. Has the same number. And right, they take up the least area of the tray. And they take up the least area of the tray. Least area of the tray. Full stop. First statement. Actually, only one statement has been given. The textbook I am writing the same. Right. What is the number of burfis that can be placed in each stack? What is the number of burfis? Number of burfis that can be placed in. Burfis that can be placed in each stack for this purpose. One thing. And your students, this statement was given in the examination as well. So just put 3 star mark. But there was one additional sub question. I'll tell you what is that additional sub question. Once you go through the given statement, that statement is a sweet seller has 420 kaju burfis and 130 badam burfis. She wants to arrange them in such a way that each stack has the same number of burfis. In every stack, some number of kaju burfis will be there and some number of badam burfis will be there. But in every arrangement, there will be same number of kaju burfis. There will be same number of badam burfis. Then, first sub question is, what is the number of burfis that can be placed in each stack? In every arrangement, total number of burfis that can be placed, that should be found out. Here, as some number of arrangements are to be made, therefore, the burfis should be distributed to those packs or boxes. Whether we are going to divide them or else multiplying them.
Divide.
So for dividing them, hence whether it belongs to HCF or LCF.
HCF, sir.
To get the answer from this statement, we have to find out HCF. Then what another question was given in the examination? Let me tell you that. Dear students, repeatedly I have been telling, don't go for hurry-burry, don't go for writing. Please do follow my instruction. The second statement was given in the examination. In every arrangement, there will be both kaju burfis and badam burfis. But the second statement was, in every arrangement, every stack, in every box, how many kaju burfis are there and how many badam burfis are there? That question was also asked. So continue the question. Right. Find the number of kaju burfis and badam burfis in each stack. This was the additional question which was given in the examination. Up to here, it is textbook only, from textbook, and this is from your previous year question paper. Okay, let's go for answering both. Yes. First, go for writing the data. It is they have given some number of kaju burfis, that is 420, and 130 badam burfis. Please write with me. Number of kaju burfis. Number of kaju burfis, it is 420. Next, number of badam burfis, it is 130. Or not? Now, let's go for calculation. There are two sub questions. Let us answer one by one. For first one, in calculation for first one, what is the number of burfees that can be placed in each stack? It belongs to HCF, right? That must be written without fail, right? Number of burfees in each stack. Number of burfees that can be placed in each stack is the HCF of, right? HCF of these two numbers, 420 and 130. As the EDL or EDA concept has been used, use it for finding the HCF. 420 is greater than 130. Then go for using Euclid's division algorithm. You can use it directly. 420 can be written as 130. How much, sir?
3, sir.
Very good. 133, sir. It is 390 plus. How much will remain?
30.
30. Remainder is not equal to 0. Continue. 130 is equal to 30. How much, sir?
4, sir.
4.
30.
4.
4 plus 10. 4
How much
plus
will remain?
10.
10. Again, remainder is
10.
not equal to 0. Then 30 can be written as 10. How much, sir?
3, sir.
3, sir.
3, sir.
Very good. Plus, remainder is
0.
very good. What will be the HCF?
10.
HCF will be
10.
10.
10.
Let us write the conclusion at last. Now, we have got here 10 as HCF. You all know that 10 represents the number of burfees that can be placed in each arrangement, each box, each bag, each tray. Followed. Now, you are going to find out the number of kaju burfees. How many kaju burfees can be placed in each stack? How do you come to know?
So,
One box. Yes, anybody want to tell?
Multiplying.
If you go from
420 by 10.
very good, very good. It is 420 by 10. Okay. Total 420 kaju burfees are distributed to some number of arrangement that we have found out. That is, assume that it is in 10 box, we have distributed 420 kaju burfees. In every box, how many kaju burfees will be there?
42.
Very good. 420 by 10.
42, sir. 42.
42. Excellent. Now, here I'll continue to write here. Yes. Right. Multiply symbol. Number of kaju burfees. It is second one. Number of kaju burfees in each stack. It is 420 by 10, which is equal to 42. Next, number of badam burfees. Number of badam burfees. How many are there?
130, sir.
130, sir.
30, sir. 130.
Very good. 130 by 10, which is
10.
10.
10.
Number of badam
42
burfees
plus 30.
each stack. Each stack. In each stack. Hope that you have understood. Now go for writing the final conclusion. Final conclusion for both the statements. First one, we have found out all the burfees can be arranged in 10 trays or 10 stacks. Right. Therefore, the number of stacks. First of all, what is the number of burpees that can be placed in each stack? Right. The number of burpees that can be placed in each stack. Number of burpees that can be placed. The number of that can be placed in each. The number of stacks. The number of stacks is 10. Then the number of burpees burpees that can be placed in each stack is 40. And
42.
number of badam burpees in each stack. In each stack is 30. Number of stacks, number of arrangements, number of packs, number of boxes, it is 10. The number of kaju burfis in each box is 42 and badam burfis in the same box is 30. Hope that you have written. These are the worked examples that they have given. Now we are moving to exercise question. So that is exercise number 1.1. Dear students, if you have read the textbook, you might have noticed one thing. I have left one logical question which was given in second page. Is it not? It belongs to an idler and exceller. Right? I think. Have you noticed that? In the second page of the chapter, one logical question.
Yes, sir.
Yes, sir.
It's very nice. I'll solve that also after completing exercise number 1.1. So you have to notice all those things. Yes. Right. Exercise 1.1. Write down. Exercise 1.1. What are the problems we solved in worked examples? Related to that, some more important statements are given in exercise 1.1. Let's go for solving them. Right. First, please go on writing with me. Don't be lagging. Right. Use Euclid's division algorithm to find the HCF of. Use Euclid's division algorithm to find the HCF of, put colon and write. First one, it is 135 and 225. It is already over. In worked examples only, we have solved it. Just write. Solve. Now, write second one. It is 196 and 38,220. Hope that you can try to solve this.
Finish, sir. 196 into 195.
195 is the HCF, sir.
Very good, really good. Yes. Now, if you have already solved, then just cross check with by observing my writing. Here, 38,220, which is greater than 196. So you can go for using Euclid's division algorithm as they have asked. Let us start dividing 38,220 by 196. Yes, here you can go for taking 3 digits. 196 twos are, it is more than 382, hence you can go for taking ones are. 196 ones are 196. Now you may subtract. 12 minus 6 is 6. Then here 7 will remain. 17 minus 9 is 8.
8.
2 will remain. 2 minus 1 is 1. 186. Have you got same?
Yes, sir.
Now carry down 2. Now it is 1,862. Observe here 196 tens are, it is 1,960. Right?
196 nines
That
are.
number is
Nines
more than
are-
12.
Nines are,
Very
sir.
good. Then it is close to 9s up. Hence we can write 196 9s up. 9 6 up. 54. 5 is the carry. Then 9 9s up.
1164.
81 plus 5, 86. 8 is the carry. 9 ones are 9. 9 plus 8. 9 plus 8 is 17. Have you got same?
Yes, sir.
Okay, then subtract. It is 12 minus 4 is 8. 5 will remain. 15 minus 6 is 9. 7 will remain. 7 minus 7 is 0. 1 minus 1 is 0. Have you got same?
Sir, it is wrong, sir. 1164,
What
sir.
it should be?
1164.
1164.
64.
1164.
No, sir, it's correct.
It's correct only. That's why we have multiplied. Next,
Sir, it is
carry
correct.
down.
Sir, 8 minus 7, 1 Allah, sir.
8 minus 7 is 1. Observe here. From 2, 4 cannot be subtracted. We have borrowed 1. It has become 12. 12 minus 4 is 8. Now it is 5. From 5, 8 cannot be subtracted. Borrow 1 from 8. So it will be 15. 15 minus 6 is 9. Here 7 will remain. 7 minus 7, 0. Hope that you have understood. Now, carry down 0, 980. See the 196 tens are 1,960. Half of that it will be 980. Hence we can write 5 is 980. It is 0. Hope that you have understood this.
Yes, sir.
Okay.
Yes,
Now,
sir.
let us
Yes,
write
sir.
38,220 as 196 195s are plus 0. In one step only we have got the answer. So the remainder is 0. Therefore, 196 will be HCF. Now you write HCF form. Therefore, HCF form 196 38,220 is 196. Followed. Have you got same?
Yes, sir. I got same, sir.
Yes, sir.
Yes,
I'll
sir.
give you next one.
Yes, sir.
I'll give you next one. Right. Third sub question. Third sub question is, it is 867 and 255. Third
51 is
sub-question.
the HCF, sir.
867 and 255. Try to find. Okay. Try to find the HCF with me.
265 threes are, sir. 255 threes are.
Okay. Good.
51 is the HCF, sir.
Very good. Oh, if it is over, then just observe my writing. It is 867 is greater than 255. Next, by using Euclid's division algorithm, 867 can be written directly or just go for dividing 867 by 255. How much, sir?
3, sir.
3 is sir.
Very good.
Threes are.
Threes are, sir.
You are right, because 253 is at 750. It is close to this. Hence, you can go for 80 is up. So 3 5s are 15 carry 1, 3 5s are 15 plus 1, 16. Carry
7,
1, 3 2s are 6. Plus 1 is 7. 7 16.
102, sir. 102.
102. 867 is equal to 255 into 3 plus 102. Remainder is 0. Sorry, remainder is not equal to 0. Hence, it can be continued. Shall we go for writing it directly? Instead of
Yes, sir.
using, very good. Instead of using the working column, I'll write it directly because it is simple number. 255, 102 is there. 102
Into
how
51. Into 2.
2,
51.
sir.
good.
2, sir.
2, sir.
102 into
102 to the 204. Subtract
51 is
255.
51 sir.
51. Very good. Now 51 is not equal to 0. Just continue. Divide 102 by 51. These two are very
2, sir.
simple numbers.
51, 2, sir. 102.
51.
51
102 is equal to 51.
51 plus
2,
0.
sir.
0. Now
0 is the remainder, sir.
51 is the HCF. Therefore, HCF of the number 867 and 255 is
51.
Hope that you have written. Now,
Yes, sir.
okay.
Yes, sir.
Now, second one, I'll rub it. Rub this one. The first question, 3 sub questions were there. We have solved all the 3. Now we are moving to the second question. The second question, just listen to me. Don't write, just listen. The question is like this. Show that any positive odd integer is of the form 6 cube plus 1, 6 cube plus 3, 6 cube plus 5. Have you not solved this one? We have already proved the statement now.
Yes, sir.
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 What
We
examples
solved, sir.
only it was over. So therefore, just try.
Solved.
Prove.
Solved is
Solved or else prove. Now, third one. Third one, they are given a statement problem. Let's go for it. Right. An army contingent is gone writing with me. An army contingent of 616 members. 616 members. 616 members is to march. Is to march. They have to march behind an army band. An army band of 32 members. 32 members in a parade. In a parade. Continue this. The two groups are to march. The two groups are to march in the same number of columns. In the same number of columns. Same number of columns. Full stop. Then, what is the maximum number of columns in which they can march? What is the maximum number of columns? Number of columns in which they can march. What is the maximum number of columns in which they can march? So, hope that you have copied this completely.
We need to find HCF, sir.
You need to find out HCF. But how did you come to know it belongs to HCF?
Sir, because they asked the maximum
Maximum
number of columns.
columns.
Maximum
Maximum.
number of
Very
columns.
good, very good. Look here. Listen carefully. Here, once you go through the statement, an army contingent of 616 members, 616 are army contingents. They have to march behind an army band members. Total 32 are there. They have to march in some number of columns. So, some number of columns. You are going to find out what is the maximum number of columns in which they can march. In how many columns they can march. If you go for observe, yes. Look here. You are going to find out the maximum number of columns in which these can march, both contingents as well as the band members. It belongs to HCF. The reason is the maximum number of columns. So let's find out the HCF. Before that, first write the data. Data. Yes, correct. You are right.
HCF is 8, sir.
Very good, very good. Right.
HCF 8, sir.
8, sir.
HCF 8, sir.
Army contingents. Number of army contingents, it is 616. Then number of band members.
32, sir.
Members, very good. It is 30. So for calculation, this first step is very important. That is maximum number of columns required. Maximum number of columns. It is the HCF of 616 and 30. Now, let us use the Euclid's division algorithm. 616 is greater than 32. Then, by using Euclid's division algorithm, 616 can be written as
32 19 ja.
9
19 ja.
Plus 8.
Very good, very good. Here, once I use the
Remainder
working
is
form.
8, sir.
Correct, correct. Here, yes. 616. Okay. 616. It should be divided by 32.
32 1
Ones are 32.
32.
11 minus 2 is 9. Then 5 minus
2.
5 minus 3 is 2. Now carry down. 6. 296. 32. How much are?
9s are, sir.
90.
288.
Ninja.
It is 32.
288.
18 carry 1. 9 3s are 27 plus 1, 28. Hope that you have got same.
Yes, sir.
8 is a reminder, sir.
8
And here is
remind
0. Now, we can write 616 as 32. 19s are
Plus 8.
Hope that you have got same. Now, 8 is not equal to 0. Continue that. 32, 32. 8 how
8
much?
4 ja.
Four, sir.
8 4 ja.
8 4
4 ja plus 0.
4 plus 0.
Very good. Yeah.
HCF of 616 and 32 is 8.
Therefore, HCF is 8. In conclusion, therefore, hence, the maximum number of columns required or the maximum number of columns in which both army contingents and band members can march in a they can march is 8. Hence, the number of columns required or directly is 8. Number of columns in which both can march is 8. So, hope that you all have written this. Now, listen to me carefully. Can we extend this question?
Yes, sir.
Anybody want to tell? How can it be extended?
Yes, sir.
What other sub question can be expected from the examination point of view?
In each column, how many?
How many column,
How many are?
how many the band
How many army are there?
Many members are required.
army contingents and band members?
Excellent. All of you have given very good response. The question that can be extended as we can also find out the number of army contingents in each column and the number of band members in each column. If it is so, then how do you find out? Don't go for writing, just only discussion. How do you find out the number of?
Divide.
Suppose we want number of contingents, army contingents.
616 by 8, sir.
Every column.
Dividing 616 and 32 by 8, sir.
Very good. It is 616 should be divided by 8 because all 616 members have been distributed to 8 columns. Very good. In every column, there will be 77 number of contingents. Then what do you say about the band members?
4 members, sir.
4.
Very good. Number of band members.
32 by 8, 4
in each
answers, sir.
column. Correct. It is 32 by 8. This is 4. So from this you can notice that just you should not see a question as question, just a question. Even you have to think how that question can be extended, how that question can be asked in the examination point of view, so that your learning will be very effective to get on the examination as well. Dear students, do one thing, just write this information in note. Right.
Yes, sir.
Note in that. Write both the points. Number of contingents in each column. Number of contingents in each column. That's equal to 616 by 8, which is equal to 77. And second one also. Number of band members in each column. In each column, that is 32 by 8, which is equal to 4. Written up. Now we are moving to next important statement, fourth one, and it has been asked in the examination. Put 3-star mark for fourth one. Right. Fourth one. Again, I am reminding that it was asked in the examination. Put 3-star mark. The statement is like this. Use Euclid's division lemma. Use Euclid's division lemma to show that the square of any positive integer, the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m, for some integer m. Hope that you have understood the statement. Before going to this statement, just we shall recall the some statement what we come across in the beginning of today's class. We have learned how to express even positive integer, how to express odd positive integers in different forms, right? Like 2q, 4q, 6q, and so on. 2q plus 1, then 4q plus 1, 4q plus 3, 6q plus 1, 6q plus 3.
Sir, I have doubt, sir.
5. Yes?
Sir, what is the difference between algorithm and lemma, sir?
Yesterday only I told, no? I'll clarify you that. Please call me separately in the evening. Okay? Yes. Just now you may go through this statement. The statement is use Euclid's division lemma to show that the square of any positive integers. In the previous statements we have come across, we have to show that a positive integer, any positive odd integer or even integer in particular form. But here it is square of any positive integer is, it will be either in the form of 3m or in the form of 3m plus 1. Got it? Now, where m is some integer. Now, please go on writing proof. Here, have they given any positive integer? Have they given?
Yes, sir. 3m plus 1.
No.
Yes, sir.
Those positive integers,
3.
square of positive
Yes, sir.
integer will be in those
3.
two forms. But my question is very simple. Have they given the positive integer?
No, sir.
Yes.
No. So let's go for assuming. What is that?
AB.
Yes.
AB and a positive integer.
Yes. Let A be a positive integer. Please write with me. Don't be lagging. Let A be a positive integer. And A is greater than B. Yes, students, everybody must turn on the video so that our technical team can give you the opportunity for asking the question and to respond to my question. Okay. Now let's use Euclid's division algorithm. According to this, we can write A is equal to BQ plus R. Then when 0 is less than or equal to R, less than 3. You may call it as statement 1. Hope that you have written. Now, anybody want to tell the next step?
Substituting B,
Sir, substituting B is equal to
is equal to 3
3.
in
Very good.
statement 1.
Yes, you are right. Substitute B equal to 3 because in the statement, in place of B, nothing but divisor, 3 is there. Substitute B is equal to 3 in statement 1. Now, we can rewrite the statement 1 as A is equal to, it is 3Q plus R, if so. So we have to use EDL or EDA, both are same. Yesterday only I told you that lemma and algorithm are one and the same. So in case of earlier one student asked me the question, now I'm going to answer for him. In case of algorithm, we will go for following the particular steps. In case of lemma, we will go for using the statement which has already been proved. Now, A equal to 3Q plus R, then what will be the possible remainders?
0, 1 and 2.
0,
1 and 2, sir.
equal to 1.
0, 1 and 2.
1
And 2.
Now,
0, 1, 2.
yes, please go on writing with me. Whenever I ask you the question, in that time only respond. If let us take 0 in place of R, if R equal to 0, then A equal to, it will be 3Q plus 0, nothing but just 3Q. Dear students, please stop
Sir,
writing.
Q is equal to M, no, sir.
No. Just listen to me carefully. Now you may stop writing. Now go through the statement. Earlier, just we used to express the even number or odd number in particular form. But here it has been given that square of any positive integer. Then what is the positive integer?
A, sir, A.
A. Then we have to write it square now.
Squaring on both sides, sir.
Yes.
Excellent. Now you write.
A
Write
square.
Squaring
On both sides. Both sides.
the sides. Just you may write only this one.
Yes,
Squaring
sir.
on
On
both
BS.
the- Now write it directly. A whole square is A square. Right? Then 3Q whole square. Just observe. Look at the board. Don't write.
9Q
whole
square.
9Q square.
Square should be applied to both. 3 square is 9Q whole square is Q square. A square equal to 9Q square. Got it? Now again stop writing. Stop writing. Please don't go for writing anything. Observe, square of any positive integer is of the form either 3m or 3m plus 1. Here we have got A square as 9Q square. It is the multiple of 3. Hence, don't write. Please observe the board. 9Q square can be written as the multiple of 3, like this. 3
3 into 3Q square, sir.
Very good. 3 into 3Q square. I'll ask you when you have to write. In that time only, please go for writing. Till then, your concentration should be on my explanation and as well as on the board. 3 into 3Q square. Now I'll write 3 as it is. In place of 3Q square, I write it as M. So here, M is
Because it is an
3Q square. Just observe it. Square of any positive integer is either of the form 3m or 3m plus 1. Now we have got 3m. You may call this statement as second. Now you may copy up to here. Please copy up to here. You have written squaring on both the sides. Now you should write A square equal to 9Q square. That's equal to 3 into 3Q square. then it is 3m because we have assumed 3q square as m. That has been written here. Call it as statement 2. Next. Let's see what happens if r equal to 1. Now this time, please start writing it. If r equal to 1, if r equal to 1, it will be a equal to 3q plus 1, right? But we want the square of that positive integer. Again, you can go for squaring on both of them.
Both sides.
I'm not going to write these words. Only first time it is enough. Here I'll write a whole square. As it is binomial, I'll apply the square. 3q plus 1 whole square.
A plus B whole square identity. We
A
should
plus B whole square.
A plus B whole square.
A plus B whole
A
square,
plus
sir.
B whole square.
You are right. Now I'll go for applying a plus b whole square identity. It is not the formula. It is an algebraic identity. Listen to me. Should listen. A plus b whole square is equal to a square plus b square plus 2ab, or a square plus 2ab plus b square. Both are same only. I'm going to apply the same. A square plus 2ab plus b square. In place of a, I'll write 3q.
3Q.
I write it directly only for the sake of making you to understand clearly. I'm using this. It is 3q whole square plus 2ab. A is
3Q plus
3q, b is 1.
3Q plus.
Then b is
1.
1 whole square. Now let me continue that here. That's equal to, that is a square is equal to 3q whole square. Apply square to both. 3 square is
9.
9q square.
plus
Plus
multiply
Q.
number. 2 3s are 6. 6
6
1s
Q.
are
6q.
6q.
6q plus 1.
plus 1. Very good. Now please stop writing. Just observe the word. Here you can notice that square of it, we are going to do the square of any positive integer. Either it will be in the form of 3m or 3m plus 1. Here, on observing these terms, you can come to know that the first two terms are common factor, right? What is the common factor?
3.
Q, sir.
Yes, 3q.
3,
But
sir.
3.
I go for
Is a-
taking
Q.
only 3. Only 3. On taking 3 as common factor, you get
3q.
3q square
plus 2Q.
plus 2q plus 1.
You can take
Plus
3Q now.
1.
3m plus 1.
Look at 3 into 3q square plus 2q plus 1. Now this can be written as 3. In place of this,
M, sir. M.
M plus 1.
M plus 1.
where m is
3m plus 1.
3Q square plus
3q
2Q.
square
3m
plus
plus
2q.
3q square plus 2q.
2q.
Now you may call it as statement 3.
3.
Got it? Yeah, right up to that.
Yes, sir.
When the teacher is explaining, your complete concentration should be on our explanation only. Don't write in between. Whenever I ask you to write, then only you just go for writing. You feel more comfortable for understanding the statements or any other concepts.
Sir, you can
Yes,
take
sir.
Q also as common factor, no, sir?
You can take Q as common factor, but here we know that it should be expressed in the form of 3m plus 1. Hence, just I have taken only 3. Understood?
Yes, sir. Understood.
Okay. Look at it. Next. If r equal to, please write with me. If r equal to, what is that?
2.
0 is over, 1 is over, next is 2. Then a can be written as
3Q plus 2.
2.
3q plus 2.
3Q plus
3q
2.
plus 2. Apply squaring on either sides.
A square is equal to 3Q plus 2 whole square.
3q plus 2 whole square.
2 whole
Can
square.
I expand it directly? Sir, my network issue. Yes. 3q plus 2 whole square. Let us go for applying the square using the identity directly. It is a square as it is.
9q square plus
9q square, sir.
9q plus
square
12q
plus
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 No. Just answer to my question.
1q plus
Just answer to my question. A square, that is 3q whole square. What it is?
9q square
9q square, sir.
9q square
plus 12q plus
plus 12q
plus 12.
Wait. 2ab. 2 into 3q into 2. 2 3s are 6, 6 2s are
12,
12.
12q plus 4
plus 4
Plus
2
4.
whole square is
12q
4.
plus 4, sir.
Like you, many will be here in the class. It may be disturbance for them. That's why you just go for answering whenever I ask you the question. Hope that you are copied
Yes,
this.
sir.
Next, it is very interesting. It should be expressed in the form of either 3m or 3m plus 1. Is there any common factor?
Yes, sir.
sir.
No
3, sir.
common factor is there. No common. Where is the common factor? Here 9, here 12, but here is 4. Common factor is there only for first two. Because
sir 4 can be written in 3 plus 1
3 sir.
multiple of 3.
3m plus
I
So
go
we can
for
split it.
4 as 3 plus 1. Q square plus 12q. 4 is to be written as 3 plus 1. Now, can we go for taking common factor with respect to first 3 terms?
Yes sir.
Sir, yes, sir. We can take answer.
Yes, sir.
it is
3 into
3
3 3s are
3q
9.
square
3q square.
plus
3
4
4q, sir.
4q
4q plus
Plus
3
1.
after the
1.
1.
plus 1
1.
But 1 is not the multiple of 3. Hence, I write it separately. Plus 1 as it is.
Yes, sir.
Got it?
Yes, sir.
This is equal to
sir
3.
plus 3m 3m plus 1
m plus
M plus
1.
3m plus 1.
Then what is
3m
m?
plus 1.
M is
3q square plus 4q plus 1.
3
plus 1. Got it? Now we will call it as statement 4. Written on.
Yes, sir.
Now, please come across this. Please come across this. Statement 2. Look at here. A square is 3m. I am highlighting this. You can also put box for that. A square is in the form of 3. Next, come across statement 3. A square is in the form of 3m plus 1. Highlight that with a box. And third one, sorry, statement 4. Here also, a square is in the form of 3m plus 1. By using all these, we can conclude that the square, don't write, observe the board. The square of any positive integer, either it will be in the form of 3m or it will be in the form of 3m plus 1. Got it?
Yes, sir.
You have understood?
Yes, sir.
Now, write the conclusion. From statement 3, statement 2, 3, and 4, we can conclude that right, the square of any positive integer integer is of the form. Either it will be 3m or it will be 3m plus 1. Hope you have written. Okay.
Sir.
Listen to me. Dear students, in the exercise number 1.1, one more statement is there. This state, that is fifth one, it is like fourth one only. Here we have taken the square of any positive integer, but in fifth one, we are going to take cube of any positive integer. So cube of any positive integer is, it will be in the form of either 9m or
9m plus 1 or 9 plus
9m plus 8. You just try to do that in home. Okay.
Okay, sir.
Now, before
Okay,
we
sir.
conclude this class, just if you have any doubt, you ask me for within a minute.
Sir, we can take 3m plus 2 or 3m plus 3 like that. Questions are not there, sir.
No. They are given for everything. Particular pattern is there. Like in 4q plus 1, 4q plus 3. Here also, either for square of any positive integer or cube of any positive integer, particular pattern is there that should be followed.
Okay, sir.
And whatever the concepts we have taught. So, wait. Suraj V. Riker. Just wait for a while. What are the concepts I have taught today? What are the problems we have solved today? They are all important in the examination point of view. So please do practice them today itself. Don't keep anything pending. Don't postpone your practicing. If you keep that as pending, you find it very difficult to follow the next classes. Okay. And today also, I'm going to give you some worksheets. So some worksheet questions in the evening at 5:30. So please work out them. And repeatedly, I've been reminding you that the questions what I'm going to give you in the worksheet, they are very important in the examination point of view. Only such questions will be given. So you have to practice them. And another important thing is you have to write the worksheet questions. Go for using the rule sheets. At the time of admission only, I told you that you just buy 2 bundles of worksheets, that is rule sheets. Use them for writing these. And soon after every chapter is over, you can go for putting tag for them, or else you may staple them. So hope that you all will follow. So with this, shall we conclude the class?
Okay, sir.
Yes, sir.
Thank you, sir.
Thank you very
Bye,
much.
sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye, sir. Thank you,
Last
sir.
information.
Bye, sir. Thank you,
Last
sir.
information I forgot
Bye,
to
sir.
tell
Thank you.
Bye, sir.
Wait, don't say bye. Just listen to me. Tomorrow you will be having the test from 10 to 10:45. So what are the
For how many marks, sir?
what are the problems we have solved till
3
today?
marks, sir.
Yeah, the questions will be given on these only. So
How many
please do
marks, sir?
practice. It is online only.
How many marks, sir?
It is for 15 marks. Even it may maximum it may extend to 20 marks. Got it? 10 to 10:45. It is used for conducting the test on the chapter real numbers for either for 15 marks or for 20 marks.
Sir,
And
we
soon
should write in paper, or you will send
Sir,
a
tomorrow
link
no
for
online
that, sir?
class.
you must write in separate sheet of paper. After writing, you have to send that your answer sheet to my WhatsApp number.
Sir, tomorrow
Then
no online
I'll
class.
give you, listen to me, I'll give you the key answer. So you have to correct your paper yourself. Okay.
Tomorrow classes are there, sir.
For correction, your promptness is countable.
Yes, sir. Okay, sir.
Sir, tomorrow classes are
Full
there,
mark,
sir.
left marks, it is left to you only.
Tomorrow classes are there, sir.
Pardon me?
Tomorrow classes are there, sir.
Tomorrow there will be no class, only test will be there. And every Sunday, test will be there.
Okay, sir. Okay, sir.
So key answers will be sent, and using
Timing,
that,
sir?
you just go for correcting your answer yourself. Then
10
after
to
that,
10:45.
10 to 10:45. After that, just 15 minutes parent-teacher meeting will be there. You just inform your parent to attend the meeting. Okay. Your presence should also be there with them. I'll discuss with them for about 15 to 20 minutes.
Okay,
With
sir.
this, let us conclude the class. Thank you
Okay,
very
sir.
much.
Bye, sir. Thank you, sir.
Thank you, sir. Bye.
Okay, sir. Bye, sir. Thank you, sir.
Bye, sir.
Thank you, sir.
Have a good
Bye,
day.
sir.
Bye, sir. Bye, sir.
Test will be conducted through Zoom only.